Okay, so next one is we have the measure of dispersion for descriptive statistics. So to describe this data, we can measure the dispersion of the data. So we have different ways to measure this dispersion. So we have the range, the variance, standard deviation, and the coefficient of variation. So basically, what the measure of dispersion tells us is how spread the the data is from the mean. So as you can see here in the graph, we have two data sets. No? So one data set here is the steeper one, and the other data set is the the lower one. No? So for the first data set, the steeper one, you can see that the spread is not that apparent. No? So the data is much more uh condensed into this portion. But if you see the latter, the other data set will be much more spread, no? So sometimes we have a data set that has the same mean but a different dispersion or variability or spread. So how do we measure this? So the first one is the range. So the range is just the difference in its maximum and minimum values. That's it, no? So that is the range. And then for standard deviation, actually we have two standard deviation, the sample and the population standard deviation. So for the sample standard deviation, we have this two formula to calculate this. So you can utilize either of this, but the advantage of the second formula is that you don't have to compute the mean anymore. No? So this is a more straightforward way to solve for the sample standard deviation. Okay, so what does the spread again no tell us about the the data? So we have three data set here, and as you can see, so x bar no is the arithmetic mean. So they have the same arithmetic mean, which is 15.5, but they have a varying standard sample standard deviation, which is s. So for data set A, we have 3.338, and then for data B, we have 0.926, and for data C, we have 4.57. So what is the difference between the three here? So as you can see, data B has a more or a less spread data. That is why it has a smaller value of S. The greater the value of S, the more spread the data is. So as you can see, it is helpful to have an information about the mean and also the standard deviation to check if the data is spread or not. Okay? So for data A and data C, it is more spread no than data B. Okay? So what are the properties of the standard deviation? So it is a measure of variation for all values of the mean, and usually the value of standard deviation is positive, no, all the time. Positive talaga dapat, no? And the value of standard deviation can increase dramatically with the inclusion of one or more outliers. So for the outliers, I will discuss this later. But basically, if you have a very large data, no, I mean, if part of your data has an outlier, which basically means it has some of the data might be too high with comparing this to the other data, then the standard deviation could be dramatically affected. So what is the unit of the standard deviation? So if this the unit of the data is, let's say, the number of students, then the standard deviation unit is also the number of students. So that goes the same with mean, no? So mean standard deviation have the same units. Okay, so we have the population standard deviation. So for population, no, we just have a different symbol to represent the standard deviation. So we have sigma, and the mean will now be mu. And as you can see, instead of n minus 1 at the denominator, we have n, no? which is the number of population in the standard deviation. So that is the main difference between the population and the sample, the symbols, and the denominator n-1 and n. So you can use either of these two formula to solve for the population standard deviation. Okay, so we have also the variance. No? So the variance is basically just the square of the standard deviation. So for the sample variance, we just square the sample standard deviation. For the population, we just square the sample or the population variance. So again, we have this. So sample standard deviation, square that, we have sample variance. We have the population standard deviation, and then square that, we have population variance. Okay, so let's now solve for, where's my, let's now solve for the sample standard deviation of this given data set. So we have only 5 no, in our data set. So how do we solve for its sample standard deviation? Okay, so what is the formula for sample standard deviation? So if you can recall, we have S is equal to the square root of 1. So I will just utilize here the formula that doesn't need the mean, no? So it is actually faster to do this if you will use this formula. So we have n sum of x minus sum of x and then squared over n times n minus 1. So how do we do this now? So the best way to do this is actually we just tabulate this data. So we have, let's say this is x or the specific xi. We have 6, 3, 8, 5, and 3. So we just find the sum of this data set. No? So do we have a calculator? Okay. So calculator, yeah. So we just find the sum of this data set. So 6, what is it not working? Yeah. So we have 6 plus 3 plus 8 plus 5 plus 3. Okay, so we have 25 as our sum. And then what will I do? So I already found this. No? So this is the summation of x. Sorry, the summation of x is equal to 25. And then what should I do here? I want to also find the summation of the x and then squared. Okay. So how do we do this? Actually, it should be the other way around. No, sorry. It should be squared, no, inside. I think this is squared inside. Okay, got it wrong now. So this should be xi squared. So we are going to sum the square of the x's. So 6 times 6 is 36. 3 squared is 9. We have 64. We have 25. And then we have 9. So the sum of the squares or x na lang, no? So this is equal to, so we will use our calculator again. So we have 143, no, for our summation of x. So the way we should do this, no, we can use now our calculator again to solve for this. So we have the given. So n here is what? So we have 1, 2, 3, 4, 5. So we have 5. So n is equal to 5. So 5 times 25 minus, we have 143 all over 5 times 5 minus 1. So the sample standard deviation is equal to the 5 minus 143 over 5 times 4. Oh, what error? Oh, I forgot to square this, no? Sorry. Okay. Okay, I think I gave the wrong formula, no? Correct. I'll just check, no? Okay, I was wrong. I was the one who was wrong. So this should be squared pala, no? So this should be squared. So we have to square this. This should be 25 times 25 is, so 25 squared, that will be 625. 625. And so yeah, let's check. We have 625. 5 times 625 minus 143 all over 5 times 4. Okay, para mali. Why is that wrong? Why? Am I wrong? Okay. Okay. Ako pala mali. Mali pala ako. Baliktad pala yung ginawa ko. Ano? So this should be the square of the, and then the square of this. Okay. Okay, this should be, ah, okay. So let's check again. Okay, sorry, mali pala na naman ako. Ano ba yan? So the sum of the, okay, this should be 625. Okay. So this should be 625. This should be 143. Right? Ayan, my fault. So 143 pala dito, ano? My bad. 143 and then 625 for the other one. Ayan. Okay, so we have 2.12. So finally, so this will be 2.12 for the sample standard deviation. Okay, so the next one here, we have also the coefficient of variation to help us describe the spread of the data. So the coefficient of variation is basically just a ratio of the sample standard deviation over the mean of the data. Okay, for the population, that will be the ratio of the population standard deviation over the mean or the population mean. So let's say we have an example here. Okay, we have an example here. So we have the average price of stock A last year, which is 1,000 pesos, and its standard deviation is 100. No? And then for stock B, we have an average price last year that is 2,000, but it has a standard deviation of 100. So to find the coefficient of variation, we just find the ratio of this two given values. No? So for stock A, we can find the coefficient of variation of this. Usually we have the sample. No? If it is not given, it is automatically said that it is a sample. So the sample coefficient of variation will be 10%, and the coefficient of variation for stock B, that will be 5%. So you can see the difference here. If the ratio of the mean and the standard deviation is low, then it will have a lower coefficient of variation. Okay, so what does it tell us? No, so both stocks A and B have the same standard deviation, but stock B is less varying compared to stock A since it has a lower coefficient of variation. No? Okay, so that will be all for this topic.